We'll practice solving a relative motion problem involving a boat crossing a river. Here's the problem. A boat heads due north at 4.0 meters per second relative to the water. The river current flows due east at 3.0 meters per second. The river is 80 meters wide. We need to find A, the boat's resultant velocity relative to the shore, both magnitude and direction, B, the time to cross the river, and C, the downstream drift. First, find the resultant velocity. The boat's velocity north and the current east are perpendicular, so we use the Pythagorean theorem. V equals the square root of 4.0 squared plus 3.0 squared, which is the square root of 16 plus 9, the square root of 25, giving 5.0 meters per second. Now find the direction using the inverse tangent. Theta equals the inverse tangent of 3.0 over 4.0, which is 36.9 degrees east of north. Next, find the time to cross. Only the northward component of velocity closes the width of the river. T equals width divided by V north, which is 80 divided by 4.0, giving 20 seconds. Finally, find the downstream drift using the eastward velocity and the crossing time. D equals V east times T, which is 3.0 times 20, giving 60 meters. Remember, when velocities are perpendicular, use the Pythagorean theorem for magnitude and inverse tangent for direction. The crossing time depends only on the velocity component perpendicular to the current.